Okay, so here we're going to look at a little bit more advanced of a principle. This is a technique we can use to make something happen when things are kind of busy and taking a long time. So in this code, we have two LEDs and a button set up. And what we're going to do is we're going to check to see if the button is pressed. And in the case it's pressed, we're going to toggle between modes. And then we're going to check, based on the current mode, we're going to switch between these patterns. Now what we see is that this pattern has two delays of 1 second each, and this one has two delays of 2 seconds each. And so as we go through the loop, when we call this function, it's going to take 2 seconds to execute this function. When we get to this one, it actually takes 4 seconds to execute. And so we're only checking to see if the button's pressed every 2 or every 4 seconds, which means that we have to kind of get lucky to press the button at the right time. Okay, and so now I'm trying to press that button. Nothing's happening. If I hold it down, I'll get it to switch, right? Because it finally registered it. I'll try to switch back. It's not seeing it. Press it a bunch of times. Hold it down. Get to switch back. Okay, that's not very convenient. It's kind of frustrating. It's not really the way we want it to work. And so we can get around this by using something called an interrupt. And so there's a couple things we have to do, and this is a little bit complicated. So the first thing we do is we need to write something called an interrupt handler. Okay, so we're going to say void interrupt handler. So we're writing a function whose job it is to handle the interrupt. Okay. All right, and so inside of our interrupt handler, we'll basically do the same thing where we check to see if the button was pressed, and we change the mode. Now we'll just take these two lines and put them right there. So we check to see, so when the button's pressed, it's going to call this. We'll change the value of that variable, and then we will do that as well. So we can actually get rid of these lines in the loop where we check the button. Okay, now to make this work, we have to do a couple of things. So we have to come up here. Anytime we are changing the value of a variable inside of an interrupt, we have to take a step to ensure that without getting too complicated, basically the compiler can sometimes do things that we don't expect, and if it doesn't think the variable is being used, it will not include it or things like that. And so we need to basically tell it that we will be using it even though it doesn't think we are. And so we call it a volatile, and that what that tells it is that don't optimize this away. It's going to be used in the interrupt. Okay, and so now we're going to say here, after we declare it as an input, we're going to do attach interrupt. Okay, and so this tells us we're going to be using an interrupt, and then we're going to use this other function, digital pin to interrupt. Okay, like that. And then we're going to choose the button pin there. And then we have to tell it what function to use. Okay, so we tell it which interrupt it's going to be. We're going to choose our function, which is our interrupt handler. And then we also need to tell it that we're going to, that when we want to get the interrupt. So there we can get the interrupt when we have a change. We can have interrupt when the voltage rises, when it goes from 0 to 1. Or we can get it when the voltage is falling, okay? Or from 1 to 0. So we'll say falling. Right there. And so we get, and it has to be all caps here. So this is a, there we go. Okay, so that's kind of a long one there, but what we're doing is, I'll pull it out here. So we're going to pass in the interrupt pin. We're going to pass in the interrupt handler, the function, right, this one right here, and we're going to say we want it when it's falling, when it's going from 1 to 0. Okay, and so now that interrupt is attached, and we have everything here we need. Now this is still not going to work the way we want it to, but it might kind of work. Okay, so we'll start our simulation. All right, so blinking, we'll press that button, So didn't switch, didn't switch. All right, so you can see it's not working. Okay, now I'm not 100% sure why it's not working. I thought it might work here. But one thing we need to do is we need to actually, what we call, debounce the button. Okay, and so that the next step is I'll show you how to do that. Okay, so I actually made a mistake here. There's only 2 pins that this can use as an interrupt, and it's pins 2 and 3. So we're going to actually make a change here. We're going to move this pin. Why is it not letting me add these? Okay, so we're going to change this LED from pin 2 to pin 4, and this button from pin 11 to pin 2. So the only pins that we can use as interrupts are pins 2 and 3. And those are the only ones, and this is specific to this particular board. So different kinds of microcontrollers have different amounts of interrupts on different pins, and so we can only use pins 2 and 3 for interrupts. And now when we run this, I also add the serial monitor here so we can watch it happen. So we have it going. We're going to press the button. We see we got the interrupt called, right? We'll press it again. It got called again. Okay, now this works great. Now the one thing that's going to happen that we don't see here in Tinkercad in this kind of ideal environment is that when you press the button, it bounces and it kind of fluctuates between different values, like between high and low a couple times. And so when you press that button, it might trigger that interrupt like 3 or 4 times. And so we have to kind of code that out of it, and we have to kind of give it a little bit of a delay before it calls the interrupt again, so that we don't, on the bounce, accidentally call the interrupt multiple times. Okay, and so the way that we're going to do that is here, we're going to make another variable, and we'll call it unsigned long, and we'll call it last interrupt. And this is going to keep track of when the last interrupt occurred. And we'll set it to be 0. And what we'll do is, in here, we're going to say if, and actually let's make one more, I apologize. We'll say unsigned, we'll just say int delay, and we'll make it maybe be like 500, so like half a second. Could probably be less than that. But what we'll do is we will say if, so we want to say the last interrupt, so we're going to check the current time. So this function here, millis, gets the current time that it's been running in milliseconds. And so the current value of the time, so we get the current time reading, and we'll use this more later, but this is kind of a different thing for us. So we're checking to see the current time, and we're seeing if that time minus the last interrupt time, just last interrupt, if that value is greater than the delay, so the amount of time that we need to wait, we can then go ahead and treat it as an interrupt. Okay, and what this does is it debounces the button. It allows us to make sure that we're not catching the bounce. And so what we need to do here, there's one last thing, is we need to set the last interrupt now to the current time, so that we know that we treated this one as an interrupt. Okay, so we start the simulation. Oh, didn't like that. Let's see. Delay declares a different kind of symbol. Oh, okay. Sorry. I just need to use a different variable. We'll call it delay time. There we go. Okay, so we press the button, it switches modes. We press the button, it switches modes again. So this is a great way to handle like pressing buttons when things are happening that take a while. And this is a pretty advanced technique, but it works really well. Just make sure that we have to use, we have to debounce it if we're using a physical button. Okay.